Welcome to this tutorial on the Test Explorer framework in YieldOptiX. This module can be accessed from the YieldOptiX drop-down menu under Test Explorer. It is designed to support comprehensive analysis of test data throughout the entire product lifecycle, from initial empty socket results through test hardware buy-off, characterization, and qualification to ramp-up and production. A data table containing thousands of devices and tests will be used in this tutorial. So, let's get started and explore how Test Explorer enhances test data analysis. After launching Test Explorer on a data table, a window appears with multiple functions. With Test Explorer, one can easily visualize binning results, generate failing test Pareto, and create industry standard plots. Plotting can also be automated using custom templates, allowing ready-to-use visualizations to be produced within minutes, even for thousands of tests, immediately after test logs are collected. The framework also includes advanced machine learning capabilities for deeper investigations. This tutorial focuses on the basic features: how to visualize binning results, how to access statistical summaries like failing test rates and CPK with a single click, and how to create both standard and advanced plots effortlessly. Creating the bin Pareto can be achieved with just 3 clicks. The first click is on the Tabulate Pareto RCA option, where the bin Pareto box is located. Once OK is clicked, for this dataset with no information on retests, Test Explorer generates a template for bin analysis, displaying a stacked bar chart with lot wafer information on the x-axis. The visualization is fully interactive, allowing a bin of interest to be clicked for further data exploration. By default, the chart represents bin distribution as percentages, but using the Jump Graph Builder panel settings, it can easily be switched to absolute counts. Additionally, the x-axis can be modified to change the layout. Instead of stacked bars, bins can also be displayed side by side for better comparison. The view can be refined by splitting pass and fail bins to obtain a relative perspective on failing bins. Other test session information can be added to break the view into more details, such as the site number column, which provides binning information per test site. Alternatively, binning behavior can be investigated based on touchdown number by dragging the touchdown column into the x-axis and switching the view to pass-fail information, simplifying the analysis. This allows tracking bin performance across multiple probe touchdowns, helping to evaluate setup performance during testing. Test Explorer's visualization is fully interactive with other jump plots and YieldOptiX modules. This means basic wafer maps can be generated, pass-fail information can be overlaid, and binning data can be interactively selected to examine how it corresponds to the wafer layout. For a more detailed numerical view, or to examine trace bin population, Test Explorer also offers the Tabulate view from the main window. This can be launched from the Tabulate Pareto RCA option and accessed through the pop-up window by selecting Tabulate. The result is a table with a default view of soft bin count. The table is fully interactive, allowing results to be broken down by any environmental factor such as lot, test hardware details, or test site number, and also changing the default count view to percentage values. To generate a failing test Pareto, the Select Tests based on Statistics option is used. This instantly produces a table displaying multiple parameters, even for hundreds of thousands of tests. The table starts with the test name, followed by key metrics such as sigma, median, mean, tested unit count, PPK, CPK, CP, out-of-spec count, out-of-spec rate, and lower and upper limits. If any of these parameters are unnecessary, they can be removed by right-clicking on the column name and disabling them from the view. The table view can be exported with colors to a new jump table or Excel file with a single click, allowing for documentation or seamless sharing, including with team members not using jump. If Excel is chosen, the exported file opens automatically without the need to search for it in the selected directory. The statistical table is fully interactive, allowing results to be sorted, for example, by out-of-spec count, with a simple right-click on the column header. If further investigation is required, plots can be generated directly from this table. Selecting a single test or multiple tests automatically filters them into the Test Explorer main window. Advanced selection functions are also available. Instead of manually clicking on rows, the Select Where function can be used from the right-click list. This allows custom selection criteria to be built, such as filtering for tests with an out-of-spec count greater than 0. Upon applying this condition, all relevant tests are automatically selected. Test Explorer counts the selected tests for analysis above the test list window. One can see that all 155 failing tests are ready for further processing. From there, the Quick Plots function can be used to generate standard industry plots, such as box plots, normal quantile plots, and parametric maps. The quick plot option has built-in logic that ensures only compatible chart types are mixed for maximum efficiency. Starting with normal quantile plots combined with basic waveform maps. After clicking OK, Test Explorer instantly generates the plots, which can be scrolled through and analyzed. The default layout presents results in a 2-column format, but with a single click, it can be switched to a 3-column or different structured view. Since the visualizations are fully interactive, any selection made in one plot is reflected across all other linked charts. Returning to the statistical table, beyond general analysis, the view can be broken down by environmental parameters. For example, performance can be examined based on factors like lot, temperature, or test hardware details. If needed, results can also be grouped by multiple attributes, such as bin information, pass-fail status, and bin names. By clicking Drill Down, results are broken down by these criteria, helping to examine the most common failing tests per bin classification. Filtering tools allow further refinement. With the filter where function, we can quickly isolate specific bins by typing a bin name, instantly narrowing down the results. Once filtered, plots for targeted tests can be generated, such as box plots, this time utilizing an additional Analyze by option in Quick Plots, which further breaks test results by the chosen session information column, like site number. Again, all visualizations remain interactive. Selecting a data point in one chart highlights it in all related views, including the waveform map, where the position units can be investigated. Coming back to quick plot features, whenever the number of unique categories is high, such as in the part ID column, Quick Plots automatically changes the default chart type from box plot to run chart, allowing for instant plotting of results with the unit's test sequence reflected on the x-axis. If a filter needs to be reset in the statistical table, a simple right-click restores the complete view. If a group of test names indicates that test conditions have been swept, such as voltage level, the results for this group can be tracked. By selecting tests in the table, they are automatically filtered in the Test Explorer main window. If one test field contains multiple voltage conditions while others do not, selecting all ensures that all related tests are included, even those that do not appear in the failing list. This provides a complete context for analyzing measurement variations. A great way to compare multiple test conditions is through parallel box plots. By selecting this option, a visualization is generated with test names on the x-axis and measurement values on the y-axis, allowing distributions to be compared. Further customization is available via the control panel, where individual data points can be toggled instead of box plots. Since this graph is interactive, selecting failing units in one box plot also highlights them in other plots and maps. Test Explorer includes a dedicated Find Fail Devices for Selected Test function, which scans all tests in the list for failures. Upon activation, a pop-up allows a pass-fail column to be created. After clicking OK, the classification is applied. With these powerful features, Test Explorer enables efficient, in-depth analysis of test results, making it an essential tool for understanding binning distributions, test failures, and parametric trends across various product lifecycle stages. Thanks for watching.